Components of electric vehicle, EV. 1. Electric motor. 2. Charger. 3. Converter. 4. Power pack, batteries. 5. Motor controller. 6. Energy management system, EMS. Motor. Power converter. Electronic controller. Auxiliary power supply. Battery. Transmission unit. Drivers. 1. Electric motor. The electric motor is used as the prime mover in an EV. Its function is to convert the energy stored in the battery pack into mechanical motion. This motor must have a high starting torque to ensure a quick acceleration. The output power of the motor is delivered to the wheels either directly or through a transaxle. Motoring and braking. While accelerating in EV, the electric motor operates in the motoring mode and the flow of power is from the battery to the wheels of the EV. Hence the battery discharges in the motoring mode. However, while braking in EV, the motor acts as a generator, regenerative braking, and the flow of power takes place from the wheels of the EV to the battery. Hence the batteries get charged during the braking. Types of motors. There are different choices of electric motors for EVs. It is possible to use DC as well as AC motors for an EV. AC motors offer many control advantages over the DC motors. But they need to use an inverter for converting the DC power from the battery into AC power. A DC shunt or separately excited motor can also be used. The power rating of such motors for smaller vehicles is up to 50 kilowatts. The electric car Reva uses a 13 kilowatts DC separately excited motor which can produce a 70 Newton meters starting torque. 2. Charger. The onboard charger of an EV is used for converting the AC supply to DC voltage of appropriate value. All these chargers are computer controlled, therefore they are called smart chargers. The output of the charger is connected to the battery pack as shown in Fig. Features of smart charger. The smart chargers have the following important features. Computer control. Built-in stabilizer. Maintains optimum charging voltage and current. Auto shut-off mechanism to avoid overcharging. 3. Converter. An auxiliary battery of appropriate voltage is normally used in electric cars to supply power to all accessories like lights, horns, etc. There is no alternator in EVs to keep this auxiliary battery charged. Therefore EVs uses a DC-DC converter which takes its input from the main battery and produces a 13.5 volts at its output which is used to charge the auxiliary battery. It is advisable to use the auxiliary battery because if the main battery is drained below its lowest value, then the auxiliary battery can be used to bring back the car home. 4. Power pack, batteries. Batteries are probably the most important component of an EV because it determines the weight and cost, range and performance of EV. The batteries used for EVs are rechargeable. Types. The following 3 batteries are used in different EVs. Lead acid batteries. Nickel metal hydride, NiM, batteries. Lithium ion, Li-ion, batteries. All these are heavy battery spaces. The main advantage of using lead load batteries is that it is a mature technology accepted by the motor industry. However, its disadvantage is its large weight and large space requirement. Lithium-ion batteries are the latest ones and they have many advantages like small size, long life, quick charging, etc. Generally, the battery pack is housed beneath the front seats in an electric car because this lowers the center of gravity of the car and improves the safety of passengers. The EV batteries can be recharged by directly plugging them into the 220 volts, 15A sockets at home or workplace. This type of charging needs about 2.5 hours for 80% charging and about 8 to 9 hours for full charging. 5. Motor controller. The function of the motor controller is to regulate the power flow from the battery pack to the motor in proportion to the pressure applied on the accelerator. The controllers used in EVs are computer controlled. They provide perfect speed control along with optimum use of energy while accelerating and braking. Thus controllers allow a bidirectional transfer of energy. The controller power rating depends on the voltage and current ranges. 6. Energy management system, EMS. EMS is the brain of EVs, as it monitors and controls all the required functions of EV. The EMS is a computer-based system that has the main function of optimizing the charging and energy output of the batteries. By doing so, EMS increases the maximum operating range and improves the performance of EVs. These systems can increase the operating range by up to 15% and battery life by up to 25%. The EMS can also predict the available range based on the current state of the battery charge. Energy management system can monitor the operation of all the subsystems by installing sensors in them. It can install sensors to check the temperature of outside and inside air, battery voltage, charging current, vehicle speed and acceleration, etc. The function of EMS. The EMS can perform the following functions: optimizing the energy flow in both directions, prediction of available range, directing the regenerative energy from wheels to battery during braking operation, to adjust the internal temperature by sensing the outside air temperature, to adjust the light brightness by sensing the external lighting conditions, proposing a suitable algorithm for battery charging, fault diagnosis in the components of the subsystems.